All right, this is our basic differentiation review sheet. So for the first one, everything's kind of lined up term. We can just take the derivative. Derivative of x squared is 2x. Bring the negative 4 down, it'd be a negative 20x to the negative 5. Pretty straightforward. No fancy rules or anything. These first few are just your basic derivative. Bring the 8 down, 16x to the 7. Bring the 3 down, 12x squared. Derivative of 3 is 0. Next one, bring the 1/3 down. 1/3 times 9 is 3. Subtract 1 from that, it'll become negative 2/3. And then 2/7 times 7 is 2x to the negative 5/7. Okay. For this one, we want to rewrite that second one. So make this 2x minus 2x to the negative 2. And now our derivative will be 2. And then negative 2 times negative 2 is positive 4, x to the negative 3. Okay. For number 5, you could FOIL all that out, but we have a product rule, so I'm just going to use the product rule. Derivative of the first is 6x plus 7. Leave the second function as is. Plus, now leave the first function as is. Times the derivative of the second, which is 3x squared minus 4x. Right, so all of that, derivative, leave the second one alone, plus leave the first one alone, derivative of the second. Okay. For number 6, we'll do this down here. We're using quotient rule. Quotient rule says take the bottom times the derivative of the top, which is 12x, minus the top times the derivative of the bottom, which is 2x, over bottom squared. Okay. So that's our derivative of that one. Number 7 also has a quotient rule look to it, although you could bring this up and make it to the negative first and use a chain rule on it, but we'll do it as if it's a quotient rule. So the quotient rule would say take the bottom, square root of x plus 3 times the derivative of the top, which is 0, minus the top times the derivative of the bottom. This is x to the 1/2, so it's going to be times 1/2 x to the negative 1/2. Derivative of 3 is 0. Over the bottom squared, and don't make the mistake of going x plus 9 on that. That bottom squared would be something different. This is fine, or because this is 0, you could just wipe that whole thing out and just have it be there. You could obviously go 6 times half, make it 3. A lot of options at that point, but this is our general derivative here. And then number 8 here is going to have a product rule to start. We have this times this, so we're going to do this as a product rule, and as we do it, we'll probably have to use quotient rule when we get to this one. So derivative of the first one is 14x to the 6 minus 2x. Okay, leave the other function as is, plus, now we're going to leave the first function alone, times the derivative of the second. And to do that, we're going to use a quotient rule. So bottom, x plus 1, times derivative of the top, which is 1, minus top, times derivative of the bottom, which is 1, over bottom squared. And if you wanted to, this would be x plus 1 minus x minus 1. This would end up to becoming 2 just on top. But again, this is your general derivative. As long as complicated as it looks, that is our derivative for that. Okay. For number 9, our derivative on this one is 5 times the derivative of cosine. Derivative of cosine is negative sine, so I'll put that negative in front of the 5. So I don't get confused. That's negative 5 sine x plus the derivative of 7x, which is 7. Okay. For number 10, this is a quotient rule. So we bring the bottom, 1 plus cosine x times derivative of the top. Derivative of 1 is 0. Derivative of negative sine is a negative cosine. Okay. Minus the top, 1 minus sine x, times the derivative of the bottom. Derivative of 1 is 0. Derivative of cosine is negative sine. All over the bottom squared. Okay. Number 11, the first derivative here is going to be the derivative of 2x cubed, which is 6x squared. And then when we go to the next one, we're going to have to use a product rule. It's x squared times cotangent. So I'm going to treat that as a product rule. So the derivative of the first, derivative of negative x squared is negative 2x. Leave cotangent alone. Now I leave the first one, negative x squared alone, times the derivative of cotangent, which is a negative cosecant squared. cotangent, cosecant doesn't come up a ton on the AP, but that is what that equals. All right. Obviously, that negative, this negative could become plus to make this a little simpler looking, but that's what we end up with. And then for number 12 here, my derivative, it's going to be a product rule. So derivative of x is 1 times secant x as is, plus x times the derivative of secant x, which is secant tangent. Okay. So that's our derivatives on that. Then we had some chain rule ones that we were going to look at here. So for number 1, it may be helpful to write this as 5 minus 3x to the 1/2. 1/2 is the outer, this is the inner. So the derivative of the outside, subtract 1. That's our derivative of the outer one. We leave the inside function alone, and then times the derivative of the inside, which is negative 3. Okay. For number 2, the cubed is the outer function, so I'm going to bring that down, drop the 2, leave the inside alone, and then times the derivative of the inside, which we're going to have to use quotient rule. So it's going to be bottom, 2x plus 3, times derivative of the top, 6x, minus top, 3x squared minus 2, times derivative of the bottom, which is 2, all over bottom squared. So that's a kind of obnoxious for sure, all right? But when you do go to do that derivative, you have to use the quotient rule there. For number 3, this is, I'm not exactly sure what letter that is, but the derivative of this, we have a product rule. So I have to do derivative of sine 2x. When I do that, it's a chain rule. 2x is inside of sine. So the derivative of sine is cosine, leave 2x alone, times 2. That's the derivative of sine 2x. We're going to multiply that by cosine 2x as is, okay? And then plus, now we're going to leave sine 2x alone, times the derivative of cosine 2x, which is also a chain rule. I have to take the derivative of cosine, which is negative sine, leave the inside alone, times 2. So another way of writing this would be 2 cosine 2x squared minus 2 sine 2x squared. That'd be a little simpler way to look at it, but I think it's the job done. Here we have 1/3 x inside of secant. So when I do this as a chain rule, I got to take the derivative of secant, which is secant tangent. We leave the inside alone. So this 1/3 x is 1/3 x inside of both of them, times the derivative of 1/3 x, which is 1/3. Okay. For number 5, the first derivative of 4x is just 4. That's no problem. When we go to do this, now we're using chain rule. 6 comes down. 6 times 3 is 18. Subtract that 1 from there. Leave the inside alone. Then times the derivative of the inside, which is 12x squared minus 8. All right, so that 4x is just 4x. We do that derivative, and then we treat that like that. And then number 6 might help you to see this as sine of 4x squared plus 1 cubed. And what we really have here is 3 functions. We have the cube, we have the sine, we have 4x squared plus 1. We're going to do a double chain on this one. 2 chains, that's right. Derivative of f is equal, bring the 3 down, squared, leave everything else the same. Okay, so I've done the derivative of the cube, leave everything else, times, now I want to do the derivative of this, which means I have to derive the derivative of the outer one, sine, so that's cosine, leave 4x squared plus 1 alone, times, now I'm ready to do the derivative of that, which is 8x. So you have to kind of do one derivative at a time as you go, leaving everything inside the same. All right? And that's our basic differentiation worksheet.